Emergency generators provide essential backup power, but their installation requires careful attention to safety and code compliance. There are several concerns that commonly arise during generator installations. Firstly, generator placement. Installing a generator inside a garage presents a significant risk of combustion gas buildup, primarily carbon monoxide. Carbon monoxide is odorless and deadly, so proper ventilation is crucial. The generator should ideally be located outside the living space and positioned away from windows and doors to prevent the infiltration of exhaust fumes. Secondly, issues often arise with main breaker connections. Triple lugging, which involves connecting 3 conductors to a single breaker terminal, is generally not recommended. This practice can lead to loose connections, overheating, and potential fire hazards. Each conductor should have its own dedicated terminal or a lug specifically designed for multiple conductors, if the breaker is rated to handle it. Additionally, cutting strands of a conductor to fit it into a breaker terminal is a hazardous practice. This reduces the conductor's current carrying capacity and can cause the connection to overheat. The conductor should be properly sized for the breaker terminal, and if necessary, a different termination method should be used. Thirdly, backfeeding the electrical grid is a critical safety concern. A backfeed connection, where the generator's power flows back into the utility grid, can energize power lines and pose a lethal risk to utility workers. To prevent this, a mechanical or electrical interlock device is mandatory. This device ensures that the generator is completely disconnected from the grid before it can start supplying power to the home. The interlock physically prevents the main breaker and the generator breaker from being on simultaneously. Fourthly, generator sizing is often misunderstood. Generator sizing should be based on the essential loads that need to be powered during a power outage. These typically include essential appliances such as refrigerators, freezers, and some lighting circuits. If the home uses natural gas or propane for heating, the heating system should also be included in the generator's load calculation. While it is possible to size a generator for whole house coverage, this is not always necessary or practical. It significantly increases the cost and size of the generator. A more efficient approach is to prioritize essential circuits and use a smaller, more manageable generator. In addition to these main concerns, there are several other factors to consider. Firstly, wiring. The wiring between the generator and the main panel should be properly sized to handle the generator's full current output. Undersized wiring can overheat and cause a fire. The wiring size should be determined based on the generator's specifications and applicable electrical codes such as the National Electrical Code or NEC. Secondly, exhaust. The generator's exhaust system should be properly vented to the outside of the building. This prevents the buildup of carbon monoxide inside the home. The exhaust vent should be made of durable, non-combustible materials and should be installed according to the manufacturer's instructions. Thirdly, maintenance. Regular inspection and maintenance are essential for ensuring the safe and reliable operation of the generator. This includes checking the oil level, air filter, and spark plugs. The generator should also be started and run periodically to ensure that it is in good working order. Improperly maintained generators can malfunction and pose a safety hazard. To ensure compliance with all the applicable codes and standards, it is always recommended to consult with a qualified electrician for any generator installation or repair. An electrician can assess the specific needs of the home, determine the appropriate generator size, and ensure that the installation is performed safely and correctly. When evaluating an existing generator installation, several key things should be looked at to determine if the installation is safe and correctly installed. 1. Is the generator located in a well-ventilated area outside of the home? 2. Are the electrical connections secure and properly torqued? 3. Is there an interlock device installed to prevent backfeeding the grid? 4. Is the wiring properly sized for the generator's output? 5. Is the exhaust system properly vented? 6. Is the generator regularly inspected and maintained? Addressing these concerns and following best practices will help ensure the safe and reliable operation of an emergency generator. The National Electrical Code, or NEC, provides detailed guidelines for the installation of generators, including requirements for wiring, grounding, and ventilation. Some specific NEC articles relevant to generator installations include Article 445, which covers generators in general. Article 700 covers emergency systems, and Article 701 covers legally required standby systems. There is also Article 702, which covers optional standby systems. Article 250 covers grounding and bonding. Additionally, local building codes may have specific requirements for generator installations. These codes often address issues such as noise levels and setback distances from property lines. An electrical interlock device is a crucial safety component that prevents the generator from backfeeding into the utility grid. There are two main types of interlock devices, mechanical and electrical. A mechanical interlock is a physical barrier that prevents the main breaker and the generator breaker from being turned on simultaneously. It typically consists of a sliding plate or a set of levers that mechanically block one breaker when the other is in the on position. An electrical interlock uses a series of relays and switches to electrically prevent the two breakers from being on at the same time. When one breaker is turned on, the interlock circuit prevents the other breaker from being energized. Both types of interlock devices provide a reliable means of preventing backfeeding and ensuring the safety of utility workers. Generator sizing is a critical aspect of generator selection. An undersized generator will not be able to supply enough power to run the essential loads, while an oversized generator will be more expensive to purchase and operate. The first step in generator sizing is to determine the essential loads that need to be powered during an outage. This typically includes appliances such as refrigerators, freezers, and lighting circuits. The power requirements of each load should be carefully calculated. The running watts and starting watts of each appliance should be taken into account. Running watts are the amount of power required to keep the appliance running, while starting watts are the amount of power required to start the appliance. Some appliances, such as air conditioners and refrigerators, require significantly more power to start than they do to run. Once the power requirements of each load have been determined, they should be added together to calculate the total power demand. A safety factor of 10 to 20% should be added to account for any unexpected loads or surges. The generator should be sized to provide at least this much power. In addition to the total power demand, the voltage and phase of the generator should also be considered. Most residential generators are single-phase, 120 volts or 240 volts. However, some larger homes may require a three-phase generator. The generator should be matched to the voltage and phase of the electrical system. Proper ventilation is essential for preventing carbon monoxide poisoning. Carbon monoxide is a colorless, odorless gas that is produced by the combustion of fossil fuels, such as gasoline and propane. Generators produce significant amounts of carbon monoxide, so it is important to ensure that they are properly ventilated. The generator should be located in a well-ventilated area outside of the home. It should be positioned away from windows, doors, and other openings to prevent the infiltration of exhaust fumes. The exhaust vent should be made of durable, non-combustible materials and should be installed according to the manufacturer's instructions. Carbon monoxide detectors should be installed inside the home to provide an early warning of any carbon monoxide buildup. These detectors should be placed near sleeping areas and on every level of the home. The detectors should be tested regularly to ensure that they are working properly. Regular inspection and maintenance are essential for ensuring the safe and reliable operation of the generator. The generator should be inspected regularly for any signs of damage or wear. The oil level, air filter, and spark plug should be checked and replaced as needed. The generator should also be started and run periodically to ensure that it is in good working order. A generator should be serviced by a qualified technician at least once a year. The technician can perform a thorough inspection of the generator and make any necessary repairs or adjustments. A qualified electrician can provide valuable assistance in the installation and maintenance of emergency generators. An electrician can assess the specific needs of the home, determine the appropriate generator size, and ensure that the installation is performed safely and correctly. An electrician can also provide guidance on the proper use and maintenance of the generator. Choosing the right type of generator is an important decision. There are two main types of generators, portable and standby. Portable generators are smaller and less expensive than standby generators. They can be easily moved from one location to another. Portable generators are typically powered by gasoline or propane. Standby generators are larger and more expensive than portable generators. They are permanently installed and are typically powered by natural gas or propane. Standby generators automatically start when the power goes out and automatically shut off when the power is restored. Portable generators are a good choice for homeowners who only need backup power occasionally. Standby generators are a good choice for homeowners who need reliable backup power during extended outages. The cost of installing an emergency generator can vary widely depending on the type of generator, the size of the generator, and the complexity of the installation. Portable generators are typically less expensive to install than standby generators. The cost of installing a standby generator can range from several $1,000s to tens of thousands of dollars. The installation cost typically includes the cost of the generator, the cost of the transfer switch, the cost of the electrical work, and the cost of the gas piping. The cost of operating an emergency generator depends on the type of generator, the size of the generator, and the amount of time that the generator is used. Portable generators typically cost more to operate than standby generators. The cost of operating a generator is primarily determined by the cost of the fuel. Gasoline-powered generators typically cost more to operate than propane-powered generators. Natural gas-powered generators typically cost the least to operate. The safe use of emergency generators requires careful attention to safety precautions. Never operate a generator indoors or in a partially enclosed space. Carbon monoxide is a deadly gas that can build up quickly in enclosed spaces. Always locate the generator in a well-ventilated area outside of the home. Never overload the generator. Overloading the generator can damage the generator and can create a fire hazard. Only connect essential appliances to the generator. Never attempt to repair the generator yourself. Always have the generator serviced by a qualified technician. Store fuel safely. Store gasoline and propane in approved containers in a well-ventilated area away from heat sources. Regularly inspect the generator. Check the oil level, air filter, and spark plugs regularly. Keep the generator clean and dry. Following these safety precautions will help ensure the safe and reliable operation of an emergency generator. Here is a more in-depth look at the electrical considerations for generator installations. The transfer switch is a critical component of a generator installation. The transfer switch allows you to safely switch between utility power and generator power. There are two main types of transfer switches: manual and automatic. A manual transfer switch requires you to manually switch between utility power and generator power. An automatic transfer switch automatically switches between utility power and generator power when the power goes out. The size of the transfer switch should be matched to the size of the generator and the electrical load. The transfer switch should be installed by a qualified electrician. The wiring between the generator and the transfer switch should be properly sized. The wiring size should be determined based on the generator's output and the distance between the generator and the transfer switch. The wiring should be installed in accordance with the National Electrical Code, or NEC. Grounding is an important safety consideration for generator installations. The generator should be properly grounded to prevent electrical shock. The grounding system should be installed in accordance with the National Electrical Code, or NEC. Surge protection is another important safety consideration for generator installations. A surge protector can protect your appliances from damage caused by power surges. The surge protector should be installed at the main electrical panel. Bonding refers to the practice of connecting all metal parts of the electrical system together to create a low impedance path for fault current. This helps to prevent electrical shock and fire hazards. All metal parts of the generator, transfer switch, and wiring should be properly bonded. When selecting a location for the generator, consider the following factors. The generator should be located in a well-ventilated area. The generator should be located away from windows, doors, and other openings. The generator should be located on a level surface. The generator should be located away from combustible materials. The generator should be located in a secure area. The generator should be protected from the elements. The generator should be easily accessible for maintenance. The generator exhaust system should be properly designed to vent exhaust fumes away from the building. The exhaust vent should be made of durable, non-combustible materials. The exhaust vent should be installed according to the manufacturer's instructions and local codes. Local codes may have specific requirements for generator installations. These codes may address issues such as noise levels, setback distances from property lines, and permit requirement. It is important to check with the local building department to determine the applicable codes before installing a generator. Permits may be required for generator installations. Check with the local building department to determine the permit requirements before starting the installation. A qualified electrician can help you navigate the permitting process. Proper maintenance is essential for ensuring the long-term reliability of the generator. Follow the manufacturer's recommendations for maintenance. Regularly check the oil level, air filter, and spark plugs. Keep the generator clean and dry. Start and run the generator periodically to ensure that it is in good working order. Have the generator serviced by a qualified technician at least once a year. Safety should always be the top priority when working with generators. Never operate a generator indoors or in a partially enclosed space. Never overload the generator. Never attempt to repair the generator yourself. Store fuel safely. Regularly inspect the generator. Following these safety precautions will help ensure the safe and reliable operation of your emergency generator.